Namaskar. Let me first give an introduction of myself to you all. I am Saurabh Srivastav. I have retired from Madhya Kshetra Vidyut Vitran Company Bhopal, and I have headed two departments there. One is maintenance and breakdown management, and the other is non-conventional energy, which deals with solar, wind generation, hydro generation, etc. So now, as you can see in this slide, our topic today of the lecture is rooftop solar and PM Surya Ghar Yojana. Now, the various subjects on which we will be dwelling in this lecture would be, as can be seen in the slide, solar rooftop, what are the advantages, what is the working. Then PM Surya Ghar Yojana, what is the outlay of the Yojana, what are the salient features. Then we'll be talking about the steps for installation of rooftop solar system, RTS system under PM Surya Ghar. Then solar panel mounting structure and solar tracker. Then what are the types of solar panels and where are they commonly used. Further, we will be talking on rooftop solar inspection, which has to be done by utility officers. Then the achievement based incentives which are being offered under the scheme to the DISCOMs, and which are the best performing states in India as per Pan India data for PM Surya Ghar Yojana.
आइए इस पाठ्यक्रम के उद्देश्य समझते हैं। आप इस पाठ्यक्रम को पूरा करने के बाद सीखेंगे सोलर रूफटॉप सिस्टम की मूलभूत कार्यप्रणाली और ग्रिड से इसके तकनीकी जुड़ाव को। प्रधानमंत्री सूर्य घर योजना के उद्देश्य, लाभार्थियों को मिलने वाली सब्सिडी और पात्रता मापदंडों को। योजना के अंतर्गत सोलर स्थापना की पूरी प्रक्रिया पंजीकरण से लेकर निरीक्षण और सब्सिडी प्राप्ति तक। सोलर पैनलों के प्रकार, माउंटिंग स्ट्रक्चर, सोलर ट्रैकर और उनकी प्रभावशीलता, डिस्कॉम की भूमिका, निरीक्षण मानदंड और प्रोत्साहन प्रणाली की समझ। देश के उन राज्यों की कार्यशैली से सीखना जिन्होंने सोलर स्थापना में श्रेष्ठ प्रदर्शन किया है। यह पाठ्यक्रम भारत सरकार की एक प्रमुख पहल प्रधानमंत्री सूर्य घर योजना और सोलर रूफटॉप सिस्टम से जुड़ी तकनीकी, प्रबंधन और क्रियान्वयन प्रक्रियाओं को सरल तरीके से समझाने के लिए डिजाइन किया गया है। इसमें आप जानेंगे कि एक आम नागरिक से लेकर डिस्कॉम अधिकारी तक की क्या भूमिका होती है और कैसे यह योजना भारत को सौर ऊर्जा की दिशा में आत्मनिर्भर बना रही है। आइए अब एक नजर डालते हैं इस पाठ्यक्रम के प्रमुख मॉड्यूल्स पर। मॉड्यूल 1, सोलर रूफटॉप सिस्टम, मूलभूत जानकारी और कार्यप्रणाली। इस मॉड्यूल में हम सोलर रूफटॉप सिस्टम के कार्य सिद्धांत, कंपोनेंट्स और ऑन ग्रिड सिस्टम की तकनीकी प्रक्रिया को समझेंगे। मॉड्यूल 2, पीएम सूर्य घर योजना, उद्देश्य और विशेषताएं। यहां हम जानेंगे योजना के मुख्य उद्देश्य, लाभार्थियों के लिए सुविधाएं और सरकार द्वारा निर्धारित वित्तीय प्रावधान। मॉड्यूल 3, सोलर स्थापना की चरणबद्ध प्रक्रिया। इस मॉड्यूल में हम योजना के तहत सोलर सिस्टम स्थापित करने की स्टेप बाय स्टेप प्रक्रिया को जानेंगे, पंजीकरण से लेकर सब्सिडी तक। मॉड्यूल 4, माउंटिंग स्ट्रक्चर और सोलर ट्रैकर। यह भाग बताएगा कि पैनल की फिटिंग कैसे होती है, कौन से मटेरियल उपयुक्त हैं और ट्रैकर तकनीक कैसे सौर ऊर्जा को अधिकतम करती है। मॉड्यूल 5, सोलर पैनलों के प्रकार और उनके अनुप्रयोग। यहां हम सीखेंगे कि कौन से पैनल कहां और कैसे उपयोगी हैं, जैसे बाइफेशियल, पीआरसी या मोनोपैरसी पैनल। मॉड्यूल 6, डिस्कॉम द्वारा स्थापना के बाद निरीक्षण। इस मॉड्यूल में हम जानेंगे कि निरीक्षण प्रक्रिया कैसे होती है, किन मानकों की जांच की जाती है और स्वीकृति कैसे मिलती है। मॉड्यूल 7, डिस्कॉम के लिए प्रोत्साहन प्रणाली। यहां हम समझेंगे कि डिस्कॉम्स को किस प्रकार प्रदर्शन के आधार पर प्रोत्साहन दिया जाता है और इसके लिए किन शर्तों को पूरा करना होता है। मॉड्यूल 8, शीर्ष प्रदर्शन करने वाले राज्य 2024। अंत में हम जानेंगे कि किन राज्यों ने इस योजना को सबसे प्रभावी ढंग से लागू किया और किन पहलुओं से वे दूसरों से आगे रहे। आइए अब पहले मॉड्यूल की ओर बढ़ते हैं।
Now, first we'll be talking about the solar rooftop system. The solar rooftop systems are of two types. One is off-grid and one is on-grid. The off-grid one has a storage facility with battery, and the on-grid one is a grid-connected solar rooftop system. Means it is connected to the utility grid. The solar panels are installed, as the name suggests, rooftop. They are installed on the rooftops of residential, commercial, institutional and industrial buildings. And the process is that DC power is generated by the panels. Then for converting it into AC for use, the inverter is there. And normally during the daytime, the sun is there, so solar generation from panels is available. And in the evening, when no generation is being done, the electricity for use is tapped from the grid. So this is how the rooftop solar system is operational. Now here is an illustration in this slide how the rooftop solar system works. There you can see atop the house there are certain panels, and these are connected to the inverter, and further there is a net meter, and the net meter is connected to the grid. Now the units which are surplus and which is generated by the solar system, they are exported to the grid, and the units, electricity units which the house owner imports from the grid, that is called the imported units. So in this slide, the installation of the rooftop system has been discussed. So firstly, the rooftop solar plant is designed and marking is done. Further civil work and curing, this involves building columns for holding the mounting structures on which the panels would be installed. And here it is particularly seen that no drilling or puncturing of the slab of the roof is done, because otherwise problems like seepage etc. would occur. So this civil work is important in the sense that the structure should be well secured on the roof, and no drilling etc. should be involved upon the slab in which these structures are being mounted. Further, module is mounted on the structures, and this is done by the installation team. Cabling is necessary, so the cabling is done the modules are connected in series with the DC cable to the inverter, and further on, because the inverter converts DC to AC, the AC cables from the inverter are running up to the evacuation point. Synchronization with the grid is done, and the inverter is charged. So seamless power distribution begins as soon as the electrical connections are in place. So this is normally a very hassle-free arrangement, and operational costs are very minimal here. Now when we look pan-India, it is important for us to know how much potential is there for solar rooftop generation. So as we can see, the brown or dark brown patches, they means their potential is highest here. The density of solar generation per meter square, the potential which we can say in kilowatt hour, that is the maximum. Let us see in the map, it is there in Ladakh. Now many of you might be wondering, Ladakh is such a cold area and there is snow etc. in those areas. How come there is so much generation? But here we have in Ladakh very clear skies, so the sun rays which fall, they have got abundance of heat, and that is why the generation potential is very good there. And you can also see in Rajasthan and Gujarat area, the Thar desert, there are also brown patches. In central India, there are a lot of brown patches in Vidarbha and MP. So here also the solar potential is very good. Further in UP, Punjab, Haryana, there is the green portion, and that is okay potential. And the blue ones, the dark blue ones, as we can see in the northeast, those have low solar potential relatively. And of course we know that Meghalaya is there. Now Meghalaya means Alay of Meg means बादलों का घर. So Meghalaya has so many clouds all the year around, and we have the Cherrapunji, which has the highest rainfall recorded in India annually. So of course, because the clouds are there, the generation would be less. This is the installation procedure of on-grid RT solar system, and the 11 steps here have been given. The PV array mounting structure is initially created. Further, जो PV modules are installed on these structures, earthing is done, and earthing of PV module frames is also done. DC cabling is the further step, then AC cabling. System protection and safety has to be seen. Then placing of signage, pre-commissioning tests, commissioning of the system, and anti-islanding functionality tests. Now, what is anti-islanding? It is a feature which is very essential from the safety point of view. When the grid is dead, or there is a shutdown on the grid, then this solar generation should not, from the house or building, it should not go to the grid, or otherwise accident might occur because of the generated current, electricity. So that is the anti-islanding feature, and these are the 11 steps of on-grid RT solar system. And of course, RT solar system, it is covering all industrial, commercial, residential, everything. This is a typical rooftop solar plant. You can see some structures, and the PV modules, panels, they are tilted towards the sun. Normally the south direction they face, and for securing the structure soundly upon the slab, we have got this concreting blocks made of typical some material, in which not much curing etc. is required also. Now this is an illustration of the rooftop solar system and the concept of net metering. The solar panels convert energy from the sun into electricity, and the solar panels are mounted upon the house, and then an inverter converts the DC generated by the solar panels into AC, and this energy is normally first utilized in the house or building itself, or if it is a school or some business institution, so it is first utilized there itself, and the surplus energy requirement is met from the grid. So units are drawn from the grid in the evening, because there is no solar generation, or even during daytime when our demand is more of that particular house or building, and the generation is not meeting the demand. So for recording these import units and export units, we have this bidirectional meter, which is called the net meter. So it measures energy used and excess energy produced.
इस मॉड्यूल में हमने सीखा कि सोलर रूफटॉप सिस्टम कैसे काम करता है, इसके मुख्य घटक कौन कौन से होते हैं, ऑन ग्रिड सिस्टम की प्रक्रिया क्या होती है, और बिजली उत्पादन से लेकर मीटरिंग तक पूरा तंत्र कैसे जुड़ा होता है। साथ ही यह भी समझा कि एप्लीकेशन, रजिस्ट्रेशन, वेंडर का चयन, कार्यपूर्ण रिपोर्ट डालना, संयुक्त निरीक्षण रिपोर्ट देना, तथा नेट मीटर लगने के उपरांत सब्सिडी हेतु आवेदन करना। यह समस्त प्रक्रिया ऑनलाइन माध्यम से पूरी की जाती है। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now the second part of our lecture today is the PM Surya Ghar Yojana. The PM Surya Ghar Muft Bijli Yojana was launched on 29 February 2024 and the outlay of the project is 75,021 crores and the final deadline for this is 31st March 2027 and the administrative approval to this was granted on 16th March 2024. Now we see the breakup of the 75,021 crores rupees outlay of the PM Surya Ghar Yojana. We can see the CFA means the Central Financial Assistance, or what we commonly call the subsidy to the residential consumers. This is 65,700 crores, means 88% of the total outlay has been reserved for the subsidy portion. Of course, this scheme is totally for domestic consumers, those who install rooftop solar panels upon their homes on the roof. Further, for incentive to DISCOMs, for good achievement based incentive, then 4950 crores have been kept. Then there is also a provision that one model solar village should be made in each district. So the village has to be converted into a solar village and all its energy requirements are to be met by solar means. So for that also 800 crores have been kept in the outlay. And as can be seen, awareness and outreach means the publicity to the program so that people become aware about this PM Surya Ghar Yojana and they more and more people apply for this. So for that 657 crores have been kept under this scheme. Now we come to the objectives and salient features of the PM Surya Ghar Yojana. This Yojana is for residential consumers only, as I have already told, and the beginning of the Yojana was from 13 February 2024 and it will be implemented till 31st March 2027. And the main objectives are that they have targeted 1 crore residential households for installations, rooftop solar installations pan-India. And through this free low cost electricity would be made available to these households. And further, renewable energy, it is a very good scheme to promote renewable energy in our country. When the target is achieved, we would be reducing 720 million tons of carbon dioxide emission during the 25 years of lifetime of the system for rooftop solar projects. And of course, the scheme would be creating solar vendors also. It would be boosting the local economy. Employment generation would also be there because of the requirements of the scheme. Then there would be manufacturing facilities would also be encouraged because there would be a chain, a network of vendors, and operation maintenance facilities would also be there. And we can already see that much of this has been achieved already. Our country has also committed to green climate and certain commitments have been done. So it is primarily our duty to ensure that the basic good thing about the scheme, about this renewable energy should also be maintained, should also be sustained by us. Recently I heard a very disturbing news. I was reading some newspaper and I found that there in some survey, GPS survey carried out through satellite in Rajasthan, South Rajasthan somewhere, thousands of trees have been cut because people they wanted to install solar generation in their fields, and shadow was coming from the fields. So this is a very sorry state of affairs, because we are creating green energy through solar panels, but if we are cutting trees because of the because we want to generate solar panel more at our place, then this is selfishness, and this is not what we want for our planet, for our future generations. So all officers of the utility, they are also bound for the commitment given by the government in the Glasgow summit, in the Paris summit upon green energy, and they should adhere to those commitments. Now, the salient features of this scheme, of course, the targeted capacity is 30 gigawatt, and REC, Rural Energy Corporation, that has been designated as the National Program Implementing Agency. And of course, we have discussed the outlay. Then you can see this solar system installed on a slanted roof of a house. So there the chimney portion has been left, no panel has been upon the chimney portion, and no panel upon the natural light portion window that has been provided on the roof, as we can see. These are more in the such type of houses with such slanted roofs. They are more in the areas where snow falls, because that is very convenient way of the snow getting out from the house.
इस मॉड्यूल में हमने सीखा कि पीएम सूर्य घर योजना का उद्देश्य क्या है, इससे आम जनता को क्या लाभ होते हैं और योजना की वित्तीय रूपरेखा क्या है। हमने यह भी जाना कि यह योजना ऊर्जा आत्मनिर्भरता की दिशा में एक बड़ा कदम है। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now this is the stepwise procedure. This is important because all of us should know it. How a consumer who wants to install a solar system at his house, what steps are to be taken by the particular consumer. Though in our Central Discom website we have given quite a detailed operating procedure SOP of this. Also we have kept some 32 FAQs, also frequently asked questions, what questions which emerge in the minds of any prospective solar prosumer. And but these steps all officers should also know, because this yojana is to be vigorously implemented in our state also. So firstly, the consumer goes for registration for in this website pmsuryaghar.gov.in, and for this the IVRS electrical connection number, his telephone number, his name, that is all required there. Further, after registration, an application in the format available on the website itself. All of these processes are online. So the application is submitted by the consumer. Then the vendor selection is done by the consumer. So for selecting the vendors, we have got this facility in the website PM Surya Ghar. State-wise and utility-wise, they have provided a list of the registered vendors. And these registered vendors only are authorized to work on this scheme. So the consumer has the option to choose whichever vendor he likes. Normally the vendor should be, I believe, should be chosen such that he should be financially sound, and he should be close to the house or the place where the consumer resides, not in some distant town, because otherwise the distances cause delays also. And so financially sound, why I am saying, because otherwise suppose there is a warranty of 5 years and and the maintenance is also be done for 5 years by the solar vendor, and the plant is to be run for 25 years normal life. So then if the say in the third year the vendors runs away or closes his business, then the consumer would be in a fix. So vendors should be chosen very discreetly. Next is designing of the solar panel. The vendor, when he is entrusted the job by the consumer, he visits the house, he sees the roof, he sees whether the roof is suitable for the plant. Suppose a consumer has a 5 kilowatt as the sanction load on his electricity bill and domestic electricity bill, and suppose he wants a 3 kilowatt plant to be installed, then there is no problem, but the roof should be suitable and sound to manage the weight of the system which would be installed there. And the vendor also sees the condition of the sunlight being received at the roof, which way the south direction is, how much sunlight can be received, how much generation is expected. All these things he sees and accordingly designs the plant. Then an agreement is done between vendor and consumer, how much costing is there, because costing there is no definite amount which can be said ki per kilowatt we have to have this much. It depends upon the type of panel, the type of structure, and the type of after sales service, say maintenance and all that, which the vendor is offering. Some vendors also offer guaranteed generation. Your annual guaranteed generation would be this much. So all this affects the costing, and that is purely between vendor and consumer, and the agreement is done accordingly. So then we have this process of solar plant installation, which is done by the vendor. Normally they have got the photovoltaic cells or the solar panels in stock. The structure is also in stock in their warehouses, but at times they have to order this from some place, and this may cause delay of a few days. Then the structure is fitted and marking of site by the vendor is done. Then we have the structure fitting. Earthing also is done of the AC, DC and lightning arrestor. Lightning arrestor is very important here because maybe it might be a 3-storied building, and further upon the roof we have this solar system, and further upon the panel the lightning arrestor is there. So the height is quite significant, and in case of any lightning or etc., then it can damage the solar panel. So with lightning arrestor, the solar panel is secured from lightning etc., because its life is also 25 years. So that way the care has also to be exercised properly. Then solar panels are installed, inverter is installed, DC DB and AC DB are installed, DC distribution board, AC distribution box. Then DISCOM team further inspects after the work completion report or WCR is submitted by the vendor. So then the DISCOM team comes there, it inspects the plant in front of vendor as well as the consumer or the house owner. So then DISCOM sees whether the system has been made as per the norms, as per MNRE guidelines and CEA standards. MNRE is Ministry of New and Renewable Energy, and CEA is Central Electricity Authority. Further, when the DISCOM approves the system, then DISCOM installs the net meter, and solar meter is installed for in Central DISCOM. It is installed for plants which have a capacity of more than 15 kilowatt generation. Otherwise, only the net meter is there. And further on, the consumer request for the subsidy and then disbursement of subsidies are also done online, and it is on the subsidy amount directly comes to the bank account of the consumer, whichever bank account the consumer has given, and this is done through MNRE. Now, this slide is something which discusses about subsidies. Now, this is what we have to publicize among the people. They should be aware that such a generous subsidy is being given by government. For residential households, the subsidy under this PM Surya Ghar Yojana is rupees 30,000 for the per kilowatt up to 2 kilowatt. Means if it is a 2 kilowatt plant, they will be getting rupees 60,000 as subsidy. And then for 3 kilowatt, additional 18,000 is there. 78,000 total for 3 kilowatt, and also this capping is of rupees 78,000 subsidy is there for any additional capacity. Suppose it is a 5 kilowatt plant, then also they would be getting a rupees 78,000 capacity. And this is quite reasonable also, because people who are not so financially well off, they can go for 1 kilowatt, 2 kilowatt or 3 kilowatt plant. So for helping those people and encouraging them to adopt solar rooftop, the government has come with such a subsidy structure. Then subsidy is also available for Residential Welfare Association Group Housing Society. GHS is Group Housing Society. So for this, only for the common facilities, this generation can be done in any group housing society, and rupees 18,000 per kilowatt is the subsidy offered up to a maximum capacity of 500 kilowatt. So the common facilities include say the park lighting, the lifts, in the multi-story also there are the common lights, and then EV charging, electric vehicle charging system, suppose the society has kept one, so that is also included in the common facilities for which this subsidy would be available. Then this is a mounting structure for the solar panel, and as can be seen, the structure are secured through blocks upon the roof. The panels are tilted so that they can receive maximum sunlight.
इस मॉड्यूल में हमने सीखा कि सोलर सिस्टम की स्थापना के लिए ऑनलाइन पंजीकरण से लेकर साइट निरीक्षण और सब्सिडी भुगतान तक कुल 24 चरण होते हैं। हर स्टेप का उद्देश्य पारदर्शिता और उपयोगकर्ता सुविधा सुनिश्चित करना है। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now we will be discussing a very important aspect, the solar panel mounting structure. Why it is so significant? You must have heard from newspaper etc. that suppose a big storm comes in the countryside or the town where these solar panels are installed on the roof, and from the newspaper or otherwise from TV channels you get the news that some solar plants have been blown away by the winds. So the structure should be such that they are able to sustain the plant even under stormy conditions. So these are to be made of galvanized iron. And why galvanized? Because they are on the roof, they are subjected to rains, and the water can rust. If it is an iron one, then the water can be rust, so they should be rust proof. So that is why a zinc coating is done upon this for galvanization, so that protects the structure from rusting etc. Then the solar panels should also be fixed properly upon the structure. This should not sway or tilt with the wind, and otherwise it would be damaging for them. And you can see the blocks, they are normally 4 into 4 inch foundation, and fasteners, good quality fasteners are used for the structure fastening. So the solar panels, they are normally installed at 30 degree angle facing the sky to extract the maximum efficiency. The normal direction is the south direction or otherwise southwest. So here in this slide we are talking further about the structure, and the best direction of the panels is south since they receive the maximum sunlight there. North is the direction we do not want to our panels to face because India lies in the northern hemisphere, so the south direction is where the system can work best and can be productive more. Similarly, the solar panel tilt angle, globally it is decided by the latitude of the location of the solar system. So the tilt angle is very important so that we can extract the maximum what the sun is offering to us here. And here are the latitudes of the leading states. There are 4 zones in the country, and these states are divided in these zones, and these latitudes are given here. Of course, we can use a solar tracker also to increase the efficiency, though this is a costly business. Now, what are solar trackers? Because you are in this line, so you should know about the solar trackers, because maybe some consumers might be wanting to install them, or some good big houses, commercial houses, business houses, or some industries. So solar tracker is a mechanism for the mounting of the panels, and they allow panel to follow the path of the sun as it moves from east to west direction during the day, and this is how maximum sunlight falls on the panel, and they give a better output. So trackers of course give a better output, but they are initially expensive also. Even the maintenance also is a bit expensive. So a proper cost benefit analysis should be done by the consumer before going for a solar tracker. Now in this illustration we see 2 types of movement. Single axis tracking on horizontal axis, and then this is the other one is on the vertical axis. So this is how a solar tracker tilts the panels and follows the path of the sun. Now you can see in this illustration the solar panels are being mounted on a slanted roof of a house, and here you can see the safety aspect has been taken care. The worker, the technician who is mounting the panels, he has secured himself with a rope which itself is secured to the array, PV array.
इस मॉड्यूल में हमने सीखा कि सोलर पैनल की स्थिरता और कार्यक्षमता के लिए सही माउंटिंग स्ट्रक्चर और झुकाव कितना जरूरी होता है। साथ ही सोलर ट्रैकर तकनीक से ऊर्जा उत्पादन कैसे बढ़ाया जा सकता है, यह भी जाना। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now we should have an idea of the type of PV panels. This is also among the topics we have decided to cover in this lecture. So there are different type of PV panels, and normally neither the consumers nor the utility people, they are knowing what are the type of panels and where they are the best optimized for use. So as you can see in this slide, there are the monocrystalline modules, mono PERC modules. Now PERC, you may want to know the details. What is the PERC acronym for? Then it is passivated emitter and rear cell technology for enhanced light absorption. Then there is the N-type TOPCon modules. So TOPCon means tunnel oxide passivated contact. So this is another design of the module. Then there are polycrystalline modules. Then there are the thin film modules. Now the advantages of monocrystalline models are their efficiency is good per square foot. They are visually appealing because they are sleek and have a black appearance. They are visually very appealing, and they are used where we intend for high efficiency in residential and commercial rooftops. Then the monoperk models, they have enhanced light absorption, and even in low light conditions they generate good solar energy. They are also very space efficient, and they are used in regions where variable weather is there. Then we have the N-type TOPCon modules. They are also of high efficiency, and they have enhanced durability in humid conditions and in conditions where the temperature fluctuates a lot. So further we have these polycrystalline modules, and they have lower production cost, and they can be used in big solar farms or cost sensitive projects, but where space is not a constraint. Then we have these thin film modules, panels. They are thin, lightweight and flexible, and because they are flexible they can also be installed on curved surface, and they are also good for portable solar chargers and flexible applications like backpacks, etc. So this way these are all different type of PV panels, and we have summarized all this in this particular slide. So we have already discussed, and these polycrystalline panels, they have a blue hue. Hue means color, and their production cost is also cheap. Then we have these bifacial solar panels also. So here the production of solar energy is done both ways. Both ways means on the top surface, of course, it is receiving sunlight. In the bottom surface, which is facing the roof surface, from that also it absorbs the heat of the roof and light emitting, light being reflected from there, and it generates solar energy. So it can boost energy production by up to 30% under high sunlight conditions. So this is bifacial panels are ideal for reflective surfaces or snowy areas. Say as per the Stefan's law, the black surface they absorb the light, but the white surface, like we are talking about snow, so the snow etc., where there is snow there is white surface, so they radiate light back whatever light is falling on them. So here the bifacial solar panels are very productive and can be used. Then we have already talked of monoperk solar panel and this passivated emitter and rear cell technology. This can reach efficiency up to 25%. Of course, normally what panels we are using presently, they are having 17 to 18% efficiency, but efficiency in bifacial can go up to 20 to 23%, and in this perk it can be 25% or even more.
इस मॉड्यूल में हमने सीखा कि विभिन्न प्रकार के पैनल जैसे बाइफेशियल, मोनो और PERC पैनल कैसे काम करते हैं और किन परिस्थितियों में इनका चयन किया जाना चाहिए। यह ज्ञान हमें लागत और उत्पादन क्षमता को संतुलित करने में मदद करता है। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now here particularly upon this chapter upon RTS inspection, rooftop solar inspection. Say a stage comes, as we had discussed earlier, when the work completion report WCR is submitted by the vendor, and the utility officers, the DISCOM officers have to visit the site and inspect the plant. So that is called rooftop solar inspection, and the utility people, all officers should be aware what are their how they have to inspect, what things they have to see in the plant. First of all, the visual inspection of the plant should be there, and checking of the MNRE guidelines, whether the vendor while constructing the plant has adhered to the uh, minimum standards which MNRE have prescribed for the plant different components. Then they have to check the workmanship, cable laying, connections, etc. The earthing values are also to be checked. Then testing of inverter functionalities, anti-islanding feature, etc. These should also be checked. Then all safety features, whether they are provided or not, in respect of earthing, lightning arrestor, height of installation of equipment, all these are to be checked in RTS also. So there are formats also about this RTS inspection, and those formats are normally to be filled. So this is an illustration of a rooftop solar plant, the structure mounted panels, and as I have stressed, emphasized before, the utility people should know what all they have to see in the solar plant when they are going for inspection. Otherwise, the vendor would take them for a ride. Suppose he has already taken the consumer for a ride, the utility people would also be taken for a ride by the vendor. So unless you have the knowledge about this plant, what all you have to inspect, then things would not be okay.
इस मॉड्यूल में हमने सीखा कि सोलर सिस्टम की गुणवत्ता और सुरक्षा की जांच कैसे की जाती है और डिस्कॉम किन मानकों पर निरीक्षण करता है। यह प्रक्रिया उपभोक्ता और सिस्टम दोनों की सुरक्षा सुनिश्चित करती है। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now under the PM Surya Ghar Yojana, as we have seen in the initial slides, there an outlay of 75,021 crores rupees has been kept, and out of this a certain portion has been kept for incentive to discoms. Of course, there is a different portion for incentive to local bodies like panchayats and all that. Suppose they also boost solar production by educating people about the advantages, and people go for it in some village or in the panchayat area. They would also be, that particular panchayat would also be receiving the incentive under the scheme. But this is what we are talking is the achievement based incentive to discoms. So this incentive to discom is based upon the solar capacity added to the base level as per the data available with MNRE, and the incentive is limited to the first 18,000 megawatt of rooftop solar capacity in the country. So the incentive, suppose relative to previous year, the capacity enhancement has been 10% to 15%. Suppose, then the incentive would be 5% of the benchmark, applicable benchmark cost. And suppose over the previous year installed base capacity, the achievement has been, increment has been more than 15%, 15%, beyond 15%, then 10% applicable benchmark of the capacity is there for the incentive. So further down in the slide it has been given the incentive will be calculated on the basis of incremental rooftop solar capacity installed by the DISCOM in their distribution area from the installed base capacity, and that is what was the capacity at the end of previous financial year, within the timeline of 12 months from 1/4/24 to 31/3/25, like that. The incentive pattern would be progressive one with higher incentive rates for higher levels as has been given in the next table. Now this table, as you can see in this slide, the parameter is there for installed capacity achieved above 10% but up to 15% over and above the installed base capacity within a financial year. Then the incentive applicable would be 5% of the benchmark cost for the capacity achieved above 10% of the installed base capacity. And in the second provision, if the installed capacity achieved is beyond 15% over and above the installed base capacity, then for the up to 15%, 5% would be there, and additively 10% of the applicable cost for capacity achieved beyond 50% would be given as incentive. So you can see it is a good incentive, and the DISCOM officers should try to achieve this. So it would be good for the financial health of the utility also. It would be encouraging to all officers and staff, and it would be a matter of pride also for the utility. For certain states, RTS capacity currently it is rupees 50,000 for general states for 1 kilowatt applicable benchmark cost. Now this is an illustration of the rooftop solar plant upon a building. Maybe it is a commercial building or some hotel.
इस मॉड्यूल में हमने सीखा कि डिस्कॉम्स को किस आधार पर प्रोत्साहन राशि मिलती है और इसके लिए किन मापदंडों का पालन जरूरी होता है। ये मॉडल राज्यों को अधिकाधिक स्थापना के लिए प्रेरित करता है। चलिए बढ़ते हैं अगले मॉड्यूल की ओर।
Now incentive is there. Let us see which are the best performing states. This is based upon the data till September 2024. So in the first 9 months of that year, from January to September, India in 2024 achieved a capacity addition of 1.9 gigawatt through rooftop solar, so which is a robust 45% growth. Means nearly half of what there was previous, it has been achieved in these 9 months. So the total capacity has been enhanced to 12.4 gigawatt by end of September 24. Now let us look at the top performing state. Of course, two new states have entered this year in 2024 relative to 2023, because in 2023 there were Rajasthan, which was placed third, and Karnataka, which was placed fifth, but they have now been replaced by other states, as we see further on. So Gujarat continues to retain the top position, and it has recorded an increase of 15.8% in capacity addition over the previous year under rooftop solar. Then Maharashtra is there. Here the state is facilitating commercial and industrial consumers with a contract demand of up to 5 megawatts to install rooftop solar along with net metering facilities. So maybe this generous condition which they have kept, that has boosted the rooftop solar capacity. And then under PM Surya Ghar also, as we can see, it has done a good job. Then Kerala has displaced Rajasthan, which was there in 2023. In 2024, Kerala has moved to the third position and then accounted for 10.6% of the installations, up by 13.6% YOY, year over year. So for this also, one factor that is being seen here, the distribution transformer capacity, how much is permitted for renewable energy connectivity. They have increased the limit from 75% to 90%. Further on, we can see Uttar Pradesh is there. It is ranked fourth, and the state is also offering subsidy from itself also. It is quite a generous subsidy for rooftop solar. So it has done a good job here and it has jumped up the ladder. Tamil Nadu is ranked 5th, up to 104.9% year over year. So there is the electricity tariffs were very high in commercial and industrial consumers there. So because of the high electricity tariffs, people, commercial and industrial consumers, they went for solar rooftop. So solar rooftop, of course, it reduces the electricity bill, and that is a lucrative for all consumers. The state has further exempted technical feasibility need for systems up to 10 kilowatt. Now this technical feasibility, MNRE has stated that it should be, there is no need of technical feasibility report, TFR, for up to 10 kilowatt solar plants under PM Surya Ghar Yojana. But it depends upon the regulator also. So in our state MP, the regulator has allowed this. We have already one of the earliest state to have gone for technical feasibility waiver up to 10 kilowatt, and several other states have also adopted this guideline of MNRE for boosting the rooftop solar.
इस मॉड्यूल में हमने सीखा कि किन राज्यों ने सोलर रूफटॉप स्थापना में सर्वोत्तम प्रदर्शन किया और उन्होंने किन रणनीतियों को अपनाया। इनसे हमें अन्य राज्यों के लिए सीख और प्रेरणा दोनों मिलती है। चलिए बढ़ते हैं कोर्स के निष्कर्ष की ओर।
Now, I would also like to state that we in India are receiving solar light. See, the sun is a Akshay Urja Strot, and we are receiving sunlight in 300 days out of 365 on an average in most of the parts of India. So this solar potential should be utilized. The sun, which is called an Akshay Urja Strot, it has been analyzed, and the people have found that it can meet the global the annual energy requirement of the whole planet 10,000 times what we are presently needing the energy. That 10,000 times it can already provide. And we are a tropical nation, we are in a tropical climate, so the sun has been very generous upon us. So we should all, as officers, in our daily life also, we should promote solar energy, and it is good for our future generations also, because it is a green energy, and it is a clean energy, it is beneficial for the environment. So it is my suggestion and request to all that we should go all the way for adopting this good and nice technology, which is a blessing in disguise for us from Surya Devta. One more thing, I would like to summarize whatever we have studied today, whatever we have talked about. And firstly, we have talked about the advantages of solar rooftop system. We have talked about the PM Surya Ghar Yojana, what are the salient features, what is the subsidy, the generous subsidy being offered by government. We have also gone through the steps of the installation of the rooftop solar system. We have talked about the solar tracker and the various type of solar panels and PV modules and where they are to be used. We have also talked about the points which are to be seen by utility officers for rooftop solar inspection, and we have talked about the incentives which the government has offered to the DISCOMs based upon their achievement. And further, lastly, we have talked about the best performing states in India. Why we talk about the best performing states? Because it is a competition, and with competition our performance also increase. When we see our neighboring state is doing good, then we also try to be shoulder to shoulder to with them. So it is a moral booster also for us. Lastly, I would also say that there would be a questionnaire which would be given to you all upon this matter of this lecture, and it will be having 10 questions. So you have to answer those questions, and based on your answers you will be issued the certificate from here. Thank you so much. Namaskar again.
इस कोर्स की समाप्ति में हम सीख चुके हैं। आइए देखते हैं सोलर रूफटॉप सिस्टम क्या होता है, यह कैसे कार्य करता है और ग्रिड से इसका संबंध क्या है। प्रधानमंत्री सूर्य घर योजना के उद्देश्य, लाभ और इसमें सरकार द्वारा दी जाने वाली वित्तीय सहायता। योजना के अंतर्गत सोलर सिस्टम की स्थापना के चरणबद्ध 24 स्टेप प्रक्रिया और ऑनलाइन पोर्टल का उपयोग। माउंटिंग स्ट्रक्चर और सोलर ट्रैकर की भूमिका, जो सिस्टम की मजबूती और ऊर्जा दक्षता सुनिश्चित करते हैं। सोलर पैनलों के विभिन्न प्रकार जैसे बाइफेशियल, मोनोपेयर, डिस्कॉम द्वारा की जाने वाली स्थापना के बाद की निरीक्षण प्रक्रिया और तकनीकी मानकों की जांच। डिस्कॉम को मिलने वाली प्रदर्शन आधारित प्रोत्साहन राशि और इसके लिए आवश्यक शर्तें। 2024 में सोलर रूफटॉप की स्थापना में अग्रणी राज्यों का प्रदर्शन और उनके सफल क्रियान्वयन के मॉडल। चलिए बढ़ते हैं अंतिम प्रश्नावली की ओर।